Address Resolution Protocol, ARP, is a protocol used in computer networks to map an IP address to a physical MAC address. ARP is essential for communication between devices on the same local network. A simplified explanation of how ARP works. 1. ARP request. When a device wants to communicate with another device on the same network, it first checks its ARP cache, which stores previously resolved IP to MAC address mappings. If the mapping is not found, the requesting device sends an ARP request broadcast message to the local network, asking, "Who has this IP address?" 2. ARP reply. The device with the requested IP address receives the ARP request and responds with an ARP reply containing its MAC address. This reply is sent directly to the requesting device, not broadcasted. 3. Updating ARP cache. The requesting device receives the ARP reply and updates its ARP cache with the newly resolved IP to MAC address mapping. This mapping is stored for future use, avoiding the need for ARP requests when communicating with the same device again. 4. Communication. With the MAC address of the destination device obtained through ARP, the requesting device can now encapsulate the data into an Ethernet frame and send it to the destination device using the MAC address. It's important to note that ARP operates within the same local network or subnet. If the destination device is not on the same network, the requesting device will use its default gateway, router, to forward the traffic to the appropriate network. ARP is a crucial part of network communication as it allows devices to dynamically discover the MAC address associated with an IP address. This helps in establishing direct communication between devices on the same network, facilitating efficient data transmission. More about ARP. Each device maintains an ARP cache, also known as an ARP table or ARP cache table. This cache stores the mappings of recently resolved IP addresses to MAC addresses. This helps in reducing the frequency of ARP requests, as devices can refer to their cache before sending a new ARP request. Gratuitous ARP. Apart from resolving IP addresses, ARP is also used for other purposes. One such use is gratuitous ARP, where a device sends an ARP request for its own IP address. This can be useful for detecting IP address conflicts or updating other devices' ARP caches with the device's MAC address. ARP spoofing. ARP spoofing is a malicious technique where an attacker sends fake ARP messages to associate their own MAC address with the IP address of another device on the network. This can lead to traffic interception, unauthorized access, or network disruption. Various security measures, such as ARP monitoring and secure ARP protocols, help protect against ARP spoofing attacks. Timeouts and aging. Entries in the ARP cache have a limited lifespan. If a device does not receive any communication from a particular IP address for a certain period, the corresponding ARP cache entry may expire and be removed. This ensures that the ARP cache remains up to date and avoids potential stale entries.